Alright, so I'm recording this video just in case for those that wanted to watch a video rather than trying to look at the PDF and try to understand it. But basically this is section 2.2, so solving absolute value equations. Okay, so I'm going to refer back to this flowchart later, but this flowchart will start to make sense as I go through the other problems. This is actually the shortcut method. Okay, but basically here, so first part, an absolute value cannot be negative. So for example, if you have something like this, absolute value of x plus 5, it cannot equal like a negative 3 or a negative 10. The reason being is because anything that's inside this absolute value, if it's negative, it's going to become positive. So this is not a true statement, right? So if you have it equal to a negative number, that can never happen. Okay, so we'll refer back to this later, but I want to show you the example. Okay, so this is the long way how you would do it, but this will hopefully give you some context before I show you the shortcut method. Okay, so from here you want to solve the equation 2 times the absolute value of x minus 5 minus 4 equals 2. Okay, so what I'm going to do is I'm going to split this up. We're gonna split this up into two functions. So if I consider just the left hand side, this is going to be y equals 2 times x minus 5 minus 4, and the other one we're going to consider later is the graph y equals 2. Okay, but I'll do that later. Okay, so we want to plot this this absolute value on the graph here. Okay, so let's think about this. So this is from the first section. So the first section earlier, we have a vertex here, h comma k. If we look at it, we're subtracting the h. This is 5. The k value is a negative 4. Okay, so basically our vertex is going to be 5 comma negative 4. If you guys don't understand how to do that, please look at the first video. Okay, the next part, we want to try graph this absolute value function. So if we want to graph this absolute value function, so basically we want to plot a point to the left of the vertex and we want to plot a value to the right of the vertex. Okay, so let's try to do that. So let's say we were to consider, let's try x equals 2 just for fun. Let's say we want to consider x equals 2, and we want to make an xy table. Okay, so we know that y is going to be this up here, so it's going to be 2, and then the absolute value of 2 minus 5 minus 4, so 2 times absolute value of negative 3 minus 4. Absolute value of 3 is just 3, so 2 times 3 minus 4. 2 times 3 minus 4 is 2. That's my y. X is 2. This goes here. So I'm plotting 2 comma 2. So it looks like that. Now, one way to think about absolute value, if you guys noticed this earlier, is whatever you do on the left hand side, it's just going to be the same as the right hand side, but it's going to just imagine that you're going to create a V. Okay, so if we start with if we know our vertex is 5 comma negative 4, if we're going to the left 3 units, this is our x. If we go to the right 3 units, we should get if we plugged in another point, that should be our other one. Now I can prove that to you if you are curious. Okay, so we take the same function earlier, 2 times absolute value of 8 minus 5 minus 4. 8 minus 5 is going to be a positive 3. And then 2 times 3 minus 4, so 6 minus 4 is 2. So that means if you plug in x equals 8, when x equals 8, y is going to be 2. So it looks something like that. Now if I went to go ahead and graph this function, if I went to go and graph it, looks something like this. Right? Looks something like this. Next part. Now we covered this. We want to try graph the line. So if we consider this part, we want to consider the line y equals 2. Now, if you guys don't remember what y equals 2 is from Alg 1, that's basically a line with a slope of 0 and a y-intercept of 2. A slope of 0 and y-intercept of 2. Okay? So my y-intercept is 2, and my slope is constantly 0. Okay? So it looks like this. Something like this. Now, in order to write the solution to this equation, we just look for where the absolute value graph intersects with the line. So it's this point and this point right here. Okay. So if we look at the x values here, we know that x is 2, and for this one, we know x is 8. Okay. So that's pretty much how you would solve this graphically. Now, there is a shortcut to this. Okay. There's a shortcut to this, and this is the flow chart that I was showing earlier. Okay. Now, if you want to solve these absolute value equations algebraically, you just follow this process. So I'll refer to this as I show you the next example. Okay. So what letter A does here, they isolate the absolute. So if they subtract 2 from both sides, the absolute value is being isolated. So you want to isolate the absolute value expression. If this absolute value is a positive number, you want to write it as 2 equations. So technically, think about it this way. If this inside is -6, you're going to get a positive 6. If the inside is a positive 6, you'll still get a positive 6. So that's why you split it into 2 different things. So you're setting the inside equal to the positive and the negative number that it's equal to. So that's this number here. So basically, 3x equals 6 and 3x equals -6. Solve for x, both x's, and then that's basically your solutions. Okay, this is the shortcut method, and I'll show you how to do this. Okay, let's say you're given this. 3 times 4x, absolute value 4x minus 5 minus 2 equals 19. Okay, shortcut method, you want to isolate the absolute value expression. Okay, so first add 2 to both sides. So basically this cancels out. So 3 times absolute value 4x minus 5, this is 21. Divide both sides by 3. Divide both sides by 3, you get 7. 21 divided by 3 is 7. Okay, rewrite as 2 equations. So if this is a positive number, so if the absolute value is positive, you want to set the inside equal to the positive number that is equal to and the negative number that is equal to. So in this case, if this is -7, then this is going to spit out a positive 7. If this is 7, basically the number on the outside is still going to be 7. So let's go and solve this. Add 5. This is 4x equals -2. Add 5. This is 4x equals 12. Divide by 4. This is x equals -1/2. Divide by 4 here. Oh, okay, whatever. Divide by 4 here. This is x equals 3. Just ignore this, I guess. I should have put it the other way. Basically, the solution, if you see it, the whole number should have been here, fraction should have been there, but that's basically how you would do it. Okay. And if you had to plot these points here, x is 3, and then x is -1/2. So it looks like that. Okay. So you could also check your work. If you wanted to check your work with this, plug in 3 here. 3 times 4 is 12. 12 minus 5 is 7. 7, and then absolute value of 7 is 7. 7 times 3 is 21. 21 minus 2 is 19. Good. Check this one. So 4 times -1/2 is going to be -2. -2 minus 5 is a -7. Absolute value -7 is a positive 7. 3 times 7 is 21. 21 minus 2 is 19. Okay. Solve each. Let's do this one, number 3. Solve each absolute value equation algebraically. Graph the number solutions on a number line. Okay. So this one here. One way to think about this is, if you guys can see it, just multiply by 2 on both sides. If you guys don't see that at all, then change it up. This would be absolute value of x plus 2 divided by 2 equals 10. Then multiply by 2 on both sides. Multiply by 2 on both sides. This cancels out. You're going to get absolute value of x plus 2 equals 20. Now you want to consider two cases. So if the absolute value is a positive number, set this inside equal to a positive and negative number that is equal to. So this is x plus 2 equals 20. X plus 2 equals negative 20. Solve for x. X equals 18. X equals negative 22. So x equals 18. X equals negative 22. And that's it. Alright. Okay, the last page. Alright, so the last page is basically the other scenarios. Okay, so we went on this side of the flowchart. Now we're going to run into situations where if you get an absolute value that is 0, equal to 0, you're only going to have one solution. Think about it, because 0 is not a positive or negative number. So basically you would only have one solution. This one, if you get, this is the case that I mentioned above. So absolute values cannot be negative. Since absolute values cannot be negative, you're not going to have a solution. Okay, so let's just plow through these three problems and we are good. Alright. So this, you want to add 3 to both sides. So what our goal? Isolate the absolute value expression. Isolate the absolute value expression. Just like that. Cancel. And this is going to be 3 over 5 multiplied by 2x minus 4 equals 0. Now this part, it says multiply both sides by 5/3. Yeah, if you understand that, go ahead and do that. 0 times 5/3 is 0. If you guys don't like it that way, change it up. Just put 3 and then 2x minus, absolute value 2x minus 4 over 5 equals 0. Multiply by 5 on both sides, cancel out. 3, absolute value 2x minus 4 equals 0. Divide by 3, it's the exact same thing. So absolute value of 2x minus 4 equals 0. You can do that. Anyway, that's 0. Rewrite as one equation. So this is what I mentioned earlier. 0, if you think about it, it's not a positive or negative number. If the absolute value is 0, you're still going to get 0. So basically, there's only one solution. Okay, add 4 to both sides. 2x equals 4. Divide by 2. X is 2. You're done. Now if you want to check your work, here, if I were to just erase this. 2 times 2 is 4. 4 minus 4 is 0. 0 times 3/5 is 0. 0 minus 3 is negative 3. Check your work. You good. Okay. Isolate the absolute value expression in each equation. Okay, so this one. Now you're going to get to the fun ones. So this is similar to part A up here. So part A, what they did is if you subtract 2 from both sides and then you divide by negative 5, you're going to get a negative 2 on this side. This is the case here. Once you isolate this absolute value expression, if the absolute value is negative, you ain't going to have a solution. Okay? So let's try this one. So 3 times absolute value of 1/2 x plus 5 plus 7 equals 5. So let's start. Subtract 7 on both sides. We want to isolate the absolute value expression. 3 times absolute value of 1/2 x plus 5 equals negative 2. Try this. So divide by 3. This is going to be absolute value of 1/2 x plus 5 equals negative 2/3. Now if you look at this, we have a negative number. This is the case. We isolated the absolute value expression. We have a negative number that is equal to. We have a negative number, there's no solution. And you're done. Number 6. This one, we want to try solve it. So same thing. Isolate the absolute value expression. Subtract 7 on both sides. This cancels. 9 times absolute value of 4 over 3x minus 2 equals 0. Now, we want to get the absolute value by itself. Divide by 9. 0 divided by 9 is just 0. So, absolute value of 4/3 x minus 2 is 0. Okay. Now if you look at this, it's equal to 0. Because it's equal to 0, think about it this way. So this, the inside can only equal 0. It can't equal anything else. Okay. So what you're gonna do is the absolute value just disappears. This is 4/3 x minus 2 equals 0. Solve for x. Add 2 to both sides. This is 4/3 x equals 2. If you guys do not like it this way, change it to 4x over 3 equals 2. Multiply by 3 on both sides. 4x equals 2. 4x equals 6. Divide by 4. X is 6 divided by 4, which is 1.5. And you're done. Whew. Okay. Hopefully that helps. If you couldn't understand the notes, I'll say 2.2 is probably easier to understand than 2.1. Okay. Please let me know if you have any questions, and I hope this helps. Bye.